Everybody, I bet you're wondering what we're doing today. So I'm going to say, what time is it? It's time to learn about intermolecular forces and the awesomeness of water. So what you do, read these pages in your book and then answer or do these things, okay? So what time is it? Time to do chemistry. All right, so here we go. So this prefix inter means between and intra means within. The reason I'm telling you this is because we're going to talk about it soon. Inter means between. So an interstate, look, this interstate connects two states, right? So here's Texas, don't mess with Texas, and here's another state over here. So an interstate goes all the way across the country connecting states. It's like holding hands. If you're holding hands with someone, you're intertwined, connected by your hands. Intra means within. So intramurals means within LT, all right? Right here in our own school building, we have our soccer league, awesome soccer league, awesome basketball league. Intra means like within. Your humerus connects your arm to your shoulder, okay? Within, all right? So, oh, look, it's the intramural football team. Okay, so what kind of bonds are covalent bonds? Well, it's sharing electrons, but it's intra, within a molecule, inside the molecule, to make the atoms stay together. Okay, so it's like the bones of a molecule. Intra, covalent bond is like, hey, what's going to hold your body together? All your bones and skin and stuff. Okay, so inter, on the other hand, means forces between molecules. So you got your handy dandy water molecule, right? And it's got an intra molecular covalent bond, but then if one water wants to hang out close to another water, it's going to have intermolecular force, a force between two molecules. So what's weaker? These, weaker. Forces between molecules are weaker by about 10. So this strong bond between H and O sharing electrons, that's intra, that's covalent. So it takes more energy to try to break that apart than it does to try to get two water molecules away from each other. Okay, so all you have to do is get to 100 degrees Celsius, and then this water molecule and that water molecule will go away from each other and be gas. But if you want to get this H away from that O, it's going to take a lot more energy. Okay, so intra is much stronger. Okay, so we got superhero Christian up here. Hi, superhero Christian. And superhero Christian is grabbing on to Matt, so Matt does not fall off the cliff, right? Right? So grabbing onto him so he doesn't fall off the cliff, right? Oh wait, Christian is not going to fall, but Matt, maybe he's going to fall to a mysterious ending. Okay, where does the bond break? So what's going to break first? This force holding them together between the two awesome kids, or the force holding superhero Christian's arm onto his shoulder there. Okay, intra is stronger, inter is weaker. So what's going to happen? Someone's going swimming. Woohoo! Okay, so intra, how do we decide on that? It's based on polarity. This is nonpolar, equal sharing of electrons, nonpolar covalent. This is polar covalent. All right, and this is ionic. Also, a metal and a metal, a nonmetal and a nonmetal and metal, this is going to usually be ionic, and this is usually going to be covalent, two nonmetals. Okay, so the way we tell what's going to hold atoms together to make bonds is polarity and electronegativity. Okay, inter, as well, usually weaker than intra, it's based on the whole molecule and the polarity of the molecule. Okay, so what kind of polarity could we have? We could have nonpolar molecules, we could have polar molecules, and we could have superpolar molecules. All right, I'm going to explain it. So what are the three forces that would hold one molecule next to another? London dispersion forces, also called van der Waals. So LDF for London dispersion forces, or van der Waals forces. Same, different name, same thing. What causes them? Electrons getting unbalanced if they have, and because electrons are moving around and one time they could be left and one time they could be right, then there's a temporary attraction to two molecules to each other. But the more atoms you have in a molecule, so the more electrons, the stronger the London dispersion force. But overall, it's pretty weak. Then there's dipole-dipole forces. So force number one, well, we're just numbering them. Another force is a dipole-dipole force between a polar molecule and another polar molecule because of the positive and negatives in a polar molecule. And then there's the superpolar force, which is called hydrogen bonding. Hydrogen bonding. Okay, hydrogen bonding. What does hydrogen bonding occur between superpolar molecules that have a hydrogen bonded to an N, an O, or an F? Okay, it's this force is much stronger than dipole or London force. That's why I say it's for superpolar molecules. All right, so dispersion forces, how do they happen? All atoms have electrons. All molecules have electrons. If in one temporary moment they are unbalanced, the electrons are unbalanced, then there's going to be a kind of positive and a kind of negative side to the molecule because it's unbalanced, and that would cause the next molecule to have that unbalance, and so on and so on. It's called an induced dipole, and it's temporary because there's no permanent separation of charge. It just happens to be that at one moment in time there's an unbalance which causes another unbalance, but it's very weak. Okay, the more atoms you have, though, the stronger it gets. All right, dipole forces happen because some molecules are polar. So let's look at this polar molecule, ClO. I'll just make it F2O, OF2. All right, so this molecule has a permanent dipole. So it's a polar molecule. So then you bring it next to another polar molecule, and the negative side, oops, I did it backwards, fluorine's going to be. So the positive side of the molecule, these are all pointing down. The negative side of the molecule would be attracted to the positive side of another molecule because of the permanent dipole. So these are polar molecules. They have a dipole arrow, and so they're permanently polar. So this molecule can be attracted to that molecule. It's stronger than dispersion forces because the dipoles are permanent. But then, what about the superpolar molecules? All right, when hydrogen is bonded to nitrogen, oxygen, or fluorine, then the polarity of the molecule is so polar that there's this force between the hydrogen of one molecule and either the oxygen, nitrogen, or fluorine of the other molecule. So this is the hydrogen bond. So this molecule is attracted to that molecule pretty strongly because of this force called hydrogen bonding. Okay, so then these two molecules will stay close to each other because they're attracted by this force called hydrogen bonding. Okay, so to have London dispersion forces, it has to be a nonpolar molecule. All right, and what makes a molecule nonpolar? Bonds canceling. Okay, so this is a nonpolar molecule, so the strongest force it would have with another one just like itself, this weak force would be a London dispersion force. If we had two of these molecules, they'd be attracted only by London dispersion forces because it's nonpolar. Nonpolar, okay, and then another one of these would only be attracted by London dispersion forces, which are temporary dipoles. Nonpolar, because look, bonds cancel, all right, nonpolar, and then even this one to that one would be attracted by a London dispersion force, which is pretty weak. All right, nonpolar, hey, this is carbon dioxide. So why is carbon dioxide a gas? Because one CO2 is not attracted to another CO2, so it won't stay liquid or solid for long. Okay, why is London dispersion called induced dipoles? Because these electrons on one atom, okay, so it might temporarily have this because of unbalance, then the next molecule would be induced to do the same thing. So it's not permanent, and then it goes back. So the temporary dipole in one induces a dipole in another. Okay, it's pretty weak. All right, which has more London dispersion force. So this is nonpolar and this is nonpolar. This will because it's got more atoms. More atoms, more mass. More mass means higher dispersion force. Okay, this one or this one? Well, this one, more atoms, more mass. DNA or helium? Well, DNA has more atoms, more mass. But then it's still London dispersion forces. It's the weakest kind of intermolecular force, but the heavier you get, the stronger the force. But it's still weak compared to dipole forces. There is a permanent dipole in this molecule. There is a negative side and a positive side to that molecule that won't go away. So then this molecule and another one just like it would be attracted to each other by a stronger force called the dipole force. NF3 is polar. Okay, polar molecule. So this molecule and another one just like it would have a dipole force. Same with OCl2. Okay, polar molecule because the bonds don't cancel. All right, whichever way it goes. Dipole, a polar molecule. All polar molecules have dipole-dipole forces, and they're stronger than dispersion because this is not temporary, it's a permanent dipole. Okay, now H bonds. N is bonded to H in this molecule, and it's got a permanent dipole, so it's super polar. It's polar, partial neg, partial pos. So another ammonia or another nitrogen trihydride, whatever you want to call it. So then the H part of this molecule would be attracted to the N part of that molecule, and this would be the hydrogen bond attraction. All right, so it happens in H2O, it happens in NH3, okay, because it has to, the H bonded to N, O, or F. All right, this is CH3Cl. The H is not bonded to an N, O, or F, so this could not have hydrogen bonding. Okay, this molecule, all right, that's this, cannot have hydrogen bonding because the H has to be directly bonded to one of those three atoms to be superpolar. Okay, so rank them. London dispersion weakest, dipole, dipole, medium, medium, hydrogen bonding strongest, like the H bond. That's compared to each other. But so what does this mean about molecules? Well, the higher intermolecular forces, the higher the viscosity, the ability to flow. Okay, the higher the intermolecular forces, the likely to be solid or liquid. All right. The higher the intermolecular forces, the harder to turn to gas. Harder to turn into gas. It takes more energy to turn it into gas. Okay. So lower intermolecular forces means easy to evaporate because the molecules get away from each other. Okay, so because of hydrogen bonding, water has some super awesome properties. Ice is more dense, ice is less dense than water, so ice floats because of hydrogen bonding. Okay, so remember in the summer it's always cooler by the lake? That's because it takes more energy to heat up the lake water, so then the air stays cooler. Water has a high boiling point because of hydrogen bonding. Water has partial positive and partial negative because of hydrogen bonding. And then some bugs can walk on water because of hydrogen bonding, so high surface tension. Okay, so differences between types of attractions. Intra is strongest. That's covalence, the ones we learned about, but we'll learn about ionic and metallic. That's holding atoms together. Inter is once you already have a molecule, what holds one molecule next to another molecule. All right. What's stronger? Let's see. Weaker than that. Okay, so intra holds those together as a covalent bond. That's stronger than what holds this molecule next to that. Okay, so what type of intermolecular forces are in highest boiling point? Strong intermolecular forces. Fastest evaporation, low intermolecular forces. Okay. Lowest boiling point means low intermolecular forces. Slowest evaporation means it wants to stick together, so high intermolecular forces. Okay, all things equal, what has stronger forces? Covalent, ionic. All right, but then of the IMFs, of the intermolecular forces, H bonding is strongest. H bonding is stronger than dipole, which is stronger than London dispersion forces. All right, so to review, inter weaker than intra. Inter are between molecules, one molecule to another. All right, inter cause some properties. All right, and the shape and the electronegativity determine the what kind of force they'll be. Okay, and water has great ability because of hydrogen bonding. So you might be saying to yourself, what time is it? It's time to look at these notes, all right? Okay. Oh, what does the red dashed line represent? So look in your book at these pictures to get an idea of what I was talking about, all right? So let's talk about what you should be able to do. Can you compare their strength? Can you talk about how water is unique because of hydrogen bonding? And then make sure you know the difference between dispersion, dipole, and hydrogen bonding. Peace out. Unit 3 is done.